So again, with rational functions, we're using zeros. That's why we have the vertical asymptote pop up on the 1. So with rational functions, the key numbers and test intervals can be extended to rational inequalities. So these two types of numbers make up the number. So the x values, so we want to find the x values for which the numerator is 0, and it's undefined, the values of x that would make the denominator. So top and bottom, that's what we want to find for these here. So we look at these here, when we're trying to see what's going to make them 0, we want to see what's going to make the numerator and denominator 0. Now, for this one here, we need it to be 0 on the one side. So for the most part, that doesn't seem that bad, right? Because what are we going to do to both sides? We're going to subtract 3. Because when I subtract 3 from one side, I get 0. On the other side, I'll have the negative 3. But I'll have this here. Yes? Any questions on this so far? Now, we can't just straight minus 3 from this here. We have to make the denominators be the... So I've got to multiply this by x minus 5 over x minus 5. We kind of got a little way we cheated a little bit with the one we did before because it was 1. So it's the same thing over itself. So we multiply the top. The denominator stays the same because 3 times x would be 3x. 3 times it's whatever we choose. We can pick one or the other. Now, we could, if we multiply 3 by negative 3, this would be negative, this would be positive, but our sign between them would be positive. If we multiplied it through by just 3, we would leave it as minus. Does that make sense? Because if we pull the negative with it, this turns into a positive. Because we're combining, we're adding. But if we multiply through just by 3, we leave the minus, and it'll apply later. So for some, it might be easier to just pull the negative with it, and then just add the terms together. Because at this point, we can do 2x plus negative 3x, which is negative x. Negative 7 plus 15 is plus, because negative and a positive, so we end up, 15's bigger, so it ends up being positive. Any questions on how we combine those? Does that make sense? So, what we want to find is where the denominator is equal to 0 and where the numerator is, because these will give us our key points. The denominator will give us actually the vertical asymptotes, and the numerator will give us where it intersects the x-axis. Can we look at this one here? We would add 5 and get what? X equals 5. So we would subtract 8 first, yes?
Oh, you subtract, okay, yeah.
So we get x equals 8. So any questions on how we got our 2 key points? We good with these here? Yes? 5 and 8. I'm going to erase this here. 5 and 8. So what is a number bigger than 8 we want to test? Doesn't matter. 10. Now we just need to plug them in. So 0, well, That would just be 8 on top, yes? And what on bottom? -5, so that's -8/5. And what do we want it to be? Less than or equal to 0. Is that less than 0? Because it's negative, it's less than 0. Let's try the middle one, 7. So -7 plus 8 over 7 minus 5. -7 plus 8 is 1. 7 minus 5 is? Is that less than or equal to 0? Last one. We'd have -10 plus 8 over 10 minus 5. On top we'd have -2, and on bottom we would have, so would this work? Yes. So we check these three here. So our intervals that work, so coming from the left, so we have -infinity, comma, 5. Now would the 5 be a bracket or a parenthesis? Exactly. It's a parenthesis. Now you might be saying it's equal to, yes? Where did we get the 5 from? We got it from the denominator. 5 is what? A vertical asymptote. Hopefully I did that correctly in the last video. I might not have with the rational function, because we might have had two parts. And if I did, that was my mistake. It should be a parenthesis, because at those vertical asymptotes we should have a parenthesis. And now this here is at the union, so greater than 8 did work, yes? Now 8 would have a what? Comma, infinity. So let's see. Yes, because if it comes out of the denominator as a key point, it means that the function's undefined at that point. So it can't reach 5, because 0 is -8/5. 4 over -1, so -4. I have a feeling it's going to do this here. I have something like, nope, that second one's wrong. Or something like this. I'm not 100% sure, but that's a rough guess. But if you grab your calculators and type it in, it will show you what the exact graph is of this function here. -8, or x plus 8 over x minus 5. And we could type that in the calculator. So really what this bottom half is doing is it's coming up like this here. And that's our function. And that's all we have to do for this here. Any questions on this here? Would we like to see another example of a rational function? Yes. So we have that there. I'm not too worried about application. So looking at these here, pick one that is a rational function. Yep. I'd say 46 or 48, because those two are on there. Because those look ugly, don't they? Which one do you want? Or just read off the one you want to do. 48?
Is greater than 48.
We need to get them on the same side of the equal sign. So it doesn't matter if we move everything to the left or everything to the right. We just need to pick one. Which way do we want to move? So I'm going to minus 1 over x plus 3 from both sides, because we're getting everything on the same side. And when we do that, we'll have 1 over x minus 1 over x plus 3 is greater than or equal to 0. Now I want one term. So if I want one term, I need the denominators to be the same. So this one here, I'm going to multiply it by x over x. Here I'm going to multiply both sides by x plus 3 over x plus 3. Now for most, we would say, okay, we're going to multiply the denominators together. I'm going to leave it as that. X times x plus 3. Because, again, when we solve, because when we find our key points, I'm going to have to solve for what the denominator is 0. And if I multiply them together, I'm going to have to pull them back apart to be able to find it. So I'm going to leave it as that. Now, the numerators we will multiply together. Well, x minus x cancel out, yes? 3. Key points. Well, we don't have anything on top, do we? No, we just have 3, yes? So is there any way to make the numerator, the top of this fraction, 0? Well, no, I mean, I can't plug any values in. It's just 3, right? On the denominator, well, x could be, or, because if it's negative 3, the x inside the parentheses would make the whole thing 0. If x is 0, well, the whole thing is 0, yes? No, let's get this right. Negative 3 and 0. So 1. Now that we have these, I'm going to erase this here. Put that down. And move this down here so we can check. So I'm just going to start from the left, negative 4. So we have 3 over negative 4 times negative 4 plus 3. So we have 3 over negative 4 times negative 1, which is 3/4. Does that make the statement true? Yes, it's greater than or equal to 0. So this works. Now we have 3 over negative 1 times negative 1, negative 1 plus 3. So that'd be 3 over negative 1 times 2, which is 3 over negative 2. Yep, would be negative. And lastly, 1. Oh, that works, sorry. I don't know why I marked that out. Because that would be positive. So, we found the ones that work. So we definitely have a parenthesis at negative infinity, and it goes all the way to, and it would be a. Nope, it's not a bracket because, again, negative 3 and 0 are both of our vertical asymptotes, or vertical asymptotes. So we have to have parentheses on both of these here. That's it. Questions on this here? We good with this here? Yeah, because the zeros from the denominator are vertical asymptotes, so the function never actually reaches there. So, like a rough sketch of the graph would be something looking like this here. And this is a rough sketch, so you could go on and graph it if you wanted to and see what it actually looks like, but it should look something like this here. Any other questions on these here? Do we feel pretty comfortable with these here? And that's all we're doing.